Hi, welcome to my channel. Today we're going to talk about an important concept in machine learning, separability. Separability determines whether a simple linear model like a perceptron can correctly classify a dataset. On the left side of the slide, we have our problem. Here, the red and the blue points represent two different classes. Notice that we can draw a straight line that cleanly separates the two classes. All the points that satisfy the OR condition lie on or above this line, while the others lie below it. This means the OR dataset is linearly separable, and the perceptron can easily learn this decision boundary. Look now at the right side, the XOR problem. Here, the points are arranged in such a way that no straight line can separate class 1 from class 0. Whenever you try to draw a line, at least one point from each class ends up on the wrong side. This means the XOR dataset is not linearly separable. This inability to draw a single straight line separating line is what made the XOR problem famous. In fact, it exposed a major limitation of original perceptron. It cannot solve problems when the classes are arranged in a pattern like XOR. The key takeaway is OR is linearly separable, so singular perceptron can solve it. XOR is not linearly separable, so we need more complex model. This insight eventually led to the invention of multi-layer networks and the foundation of deep learning. Understanding these differences is crucial because it shows why deeper architecture become